So welcome back. As you can kind of see, looks like words. Yes, words and math don't mix, but keeping that in mind, in the real world, things start out as thoughts, then they become words, then they typically become equations. So there's this kind of a flow that we're picking up on. So again, we're giving you some hints here. We're saying graphing a linear relationship. In the real world, it may not even be a linear relationship. So we're just working on one type of relationship that does exist out there. And we want to practice again with this coordinate plane. So here's our directions. Write an equation that describes, left off my R there, that describes the following relationship between x and y. Then graph the relationship. So here's my little phrase. Y is 3 less than 3 times x. What I got to do is translate that into an equation. So remember, an equation has to have a left side and a right side, and it has to have an equal sign in there. So we're looking for those little cues to help us piece this thing together. So I have y is, to me, that kind of stands for y is equal to. Is can be a synonym for is equal to. So in this case, I'm picking up on y is, and what is it equal to? 3 less than 3 times x. What's confused me a little bit is this 3 less than. This part here, 3 less than. If I look at this problem right here, 5 less than 20. What is 5 less than 20? 5 less than 20 would be 15. Now, mathematically, would that be 5 minus 20, or would that be 20 minus 5? So when we pick up on subtraction, order does matter. So if I say 5 less than, I'm actually taking that away from whatever. In this case, I'm taking that away from a 20. Over here, when I say 3 less than this actually has to go first, because I'm taking this away from that. So 3 times x, we know that the word times actually implies multiplication, so that means 3x. Less than means to take away this 3. So I have then y is 3 less than 3 times x. So my 3 times x, and that less than 3 kind of means to subtract it from that. Well, there you go. There's my equation. So now I have to decide, what strategy do I want to follow? I find that since y is equal to, I think using the 3 solution method is probably the best. Because all I got to do is pick a value for x, and then automatically I'm going to be able to solve for y. So I'm going to substitute 0 in for x, and ironically, remember when I pick 0 for x, I'm actually finding the y-intercept anyway. I'm finding one of those. So that's going to be y equals then 3 times 0 minus 3. We can see that this disappears, and that's going to leave me a negative 3. So when a 0 went in, I ended up with a negative 3. So 0, negative 3 would be an ordered pair. And using the 3 solutions, I usually just pick easy numbers. Since this is all no fractional stuff, I would just pick 1. Y is equal to 3 times 1 minus 3. Well, 3 times 1 is 3. 3 minus 3 is 0. So I end up with 1, 0. Ironically, I've actually found the x-intercept. So, and if I want to go ahead and do a third point, that's what I was out to do. Pick 2. Y is equal to 3 times 2 minus 3. 3 times 2 is 6. 6 minus 3 is going to give me 3. So I picked a 2 for x, and y gave me a 3. So those are my solutions. So now I'm able to graph my relationship. So 0, negative 3. 1, 0. And 2, 3. So that would be my relationship. From there, don't forget to draw your line. Once you plot those points, that's not your final answer. The relationship is actually the line itself. So I have to line these 3 points up, and I'm going to try to draw a line through those 3 points. So that would be my setup there. Okay? So I know that's kind of intimidating, but as you get more familiar with vocabulary, this becomes a little bit more second nature. So you have to really pay close attention to examples in these cases. So everyone's a little bit unique. So stay tuned.